Here's the solution to day 1, problem 1. Question A, rewrite the number into standard form. So let's start by copying that number down, and then times 10 to the third power. And so we want to multiply this number 9.05 times 10 to the third power. Each time you multiply by a 10, the decimal point will move one position to the right. And so if you multiply by 10 3 times, that means to move the decimal point 3 spots to the right. Let's do that. 1, 2, and 3. The decimal point will end up right here, and we need to fill in a placeholder 0. And so that creates the number 9050 with the decimal point at the very end. So 9,050. Now question B. Let's copy the question down. 505 700 000. The decimal point is not shown anywhere, so it's automatically at the very end. So we have this number 505,700,000. It's a very large number, and so a scientist would want to write this number in a more compact way in scientific notation. To do that, we want to have only one number to the left of the decimal point, and so let's put the decimal point here, so that the number 5 is to the left of the decimal point. Let's count how far we need to move it. 1, 2, 3, 4, 5, 6, 7, 8 spots. And that will create the number 5.057. And then it's not necessary to write all these additional zeros. That's why scientific notation is faster for this particular number. And then times 10, and because it was 8 spots, the exponent on the 10 is an 8. Now day 1, problem 2. Solve this equation for the variable n, and then in part B, we'll check that we have the right answer. So in question A, let's copy that equation down so that we can work with it. And locate the equal symbol and draw a vertical line downwards through the equal symbol. Now we want to solve this for the variable n. That means we want to isolate an n term, but there's an n term here and another n term here. We can't have n terms on both sides of the equation and then solve it. So let's remove this n term. The opposite of negative 2n is to say plus 2n. And to maintain balance, plus 2n on the left side of the equation as well. 3n plus 2n is 5n. The plus 1 can be brought down next to the 5n. Negative 2n plus 2n makes 0n, so there's a 0 here. And then the positive 16 can be brought straight down. Here is our new equation. We want to get the letter n alone, so let's first get this n term alone. Next to the n term is plus 1. Let's remove that. Subtract 1, subtract 1. The 5n comes straight down. Positive 1, subtract 1 makes 0. And this equals 16 subtract 1 is 15. So we have 5 times n equals 15. 5 times some number equals 15. And we can solve that for n to get 3. 5 times 3 makes 15. So we think that the answer is n equals 3. And in part B, we can check to see if that's correct. So take the original equation, and let's put 3 in place of the letter n. So 3 add 1 equals negative 2 times 3 plus 16. We need to figure out if this expression to the left of the equals is really equal to this expression to the right side of the equals. So let's work these out. 3 times 3 is 9, plus 1 is 10. Negative 2 times 3 is negative 6. And then negative 6 plus 16 is 10. So does 10 equal 10? Well, of course it does. This checks, and that means that n equals 3 is the correct value for n.